the first video of this lecture, we defined a series as a sum of a sequence, the infinitely many terms in a sequence. And then we saw that we can compute the value of a series exactly when it's a geometric series or a telescoping series. For geometric series that converge, we have a really nice formula, and we explained where that formula comes from. And for telescoping series, sometimes we get so much cancellation that our sum of infinitely many terms leaves us with only finitely many terms that don't cancel. But these are the special cases. Usually, we just have no way of saying the exact value of a series when it converges. So instead of saying, what is the value of this series, what we're going to settle for is whether it converges or diverges. So the big picture, the goal of chapter 11, the last big unit of this course, is to understand when does a series converge and when does it diverge. At the very end, we'll talk about series that are associated to functions and things like power series expansions of a function, and that'll help us integrate things that we didn't know how to integrate before. And we'll talk about things like Taylor and Maclaurin series. But the big first part of this is just understanding when does a series converge and when does it diverge. And what we're going to do for the next several lectures is learn a bunch of tests that you can apply to tell whether a series converges or diverges. When it tells you that a series converges, it's not going to tell you this exact value of the series, only that it converges or that it diverges. So the last video that we're doing here, the goal is just going to be to explain the first one of these tests, which is sometimes called the divergence test or the nth term test. They mean exactly the same thing. So what does it say? So you have a sequence that's given by an. And if the limit as n goes to infinity of an is not equal to 0, if it's not equal to 0, that's including the cases when the limit is equal to maybe plus or minus infinity, or if the limit does not exist. If anything is true other than the limit exists and is equal to 0, then if you take the series that you get from these ANs, it diverges. That the only way for a series to converge is if the limit of the ANs is 0. That if the limit is not 0, there's no way that the series converges. So let's look at some examples. Let's say we have a series which is given by a sum from n equals 1 to infinity of n over n plus 1. What does this look like? Well, we have 1 over 2 plus 2 over 3 plus 3 over 4 plus. And the point is that the limit as n goes to infinity of n over n plus 1 is 1. It's not 0. So by the divergence test, this series diverges. It diverges because we're adding up the terms of a sequence where the limit of the sequence is not 0. As you go along and look at the partial fractions, the partial sums, the things that you get by adding up the terms so far, we get 1/2 plus 2/3 plus 3/4 plus 4/5. And that sequence is not approaching a limit because when n is really large, each time we add a new term, we're changing the value of that partial sum by something very close to 1. So it's like we're adding something close to 1 and adding something close to 1 and adding something close to 1. And we're getting something that's going off to infinity. So I'll pause and erase, and we'll look at 2 more examples of series that we can think about using this divergence test. Let's look at our next example of a series, the sum from n equals 1 to infinity of arctan of n. So think of this thing that we're adding as being like an. And we want to see what the divergence test says. So let's look at the limit as n goes to infinity of arctan of n. So that's asking what kinds of angles are giving values of tangent that are getting larger and larger and larger and larger. Well, this is something we talked about in a previous video, but I'll just remind you. Tangent is sine over cosine. So if you want sine over cosine to be really large, sine can never get that large. It's always at most 1. But if the denominator is really, really, really small, then this ratio can be really large. So what kind of angle gives a value of sine close to 1 and cosine really, really small is something close to pi over 2. So this inverse trig limit is pi over 2, which is not equal to 0. So we're adding up a bunch of things, and those things are not going to 0. So there's no way that this series can converge. So this is not equal to 0. So by the divergence test, the series diverges. Let's look at one more example. Let's take the sum from n equals 1 to infinity of cosine of n. Same idea. Let's look at the limit as n goes to infinity of cosine of n. And what is this limit? Well, for some values of n, this is close to 1. Sometimes it's close to -1. Sometimes it's close to 0. This limit does not exist. So by the divergence test, this series also diverges. OK, so what is this telling us? We start with a series. One thing we can always do is check the limit as n goes to infinity of the things that we're adding up. If that's not 0, we're done. We know the series diverges. But what if it is 0? So let me just point out something that's really important here, which is if we take the sum from n equals 1 to infinity of an, this could diverge even if the limit as n goes to infinity of an is equal to 0. So what I'm saying here is the divergence says when this limit is not 0, you diverge. What it doesn't say is if the limit is 0, then you converge. If the limit is 0, maybe you converge and maybe you diverge. So just to give an example that we'll see a little bit later, this is an important thing to start keeping in mind. So for example, the sum from n equals 1 to infinity of 1 over n diverges. This diverges even though we're adding up a bunch of things that are getting closer and closer to 0. The problem is they're not getting closer and closer to 0 fast enough. And this is exactly the kind of thing that we'll deal with in the next video when we learn our next test. So when the limit of your terms is not 0, your sequence diverges. When the limit is 0, maybe you converge, maybe you diverge. You have to do another test. So the next thing we're going to do is learn a bunch of new tests.